Geometry students, welcome back. Today we're taking on 2.3 biconditionals and definitions. This is a continuation of conditional statements and some of the logic and reasoning associated with it there. Let's go ahead and get started. Biconditional. What does that mean? Well, we have but conditional. We already know what a conditional statement, an if-then statement, but now we have biconditional. Bi means two, like bicycle, it means two wheels. Biconditional means two statements. So what is it all about? Well, a biconditional statement combines a true conditional with its true converse. So that's the important thing here. Number one, we have to have, if you recall, it looks like this. We have P, arrow, Q. Okay, we have to have a true, let's use purple, we have to have a true conditional statement. So this needs to be true. Okay, now a biconditional combines this with, whoops, this goes second. It's converse. As you remember, converse, we switch it around. We have the conclusion come first. And then it leads to the hypothesis, an if-then statement, but this time it's switched with the conclusion first, hypothesis second, and this also needs to be true, okay? So that is like the prerequisite for something to be a biconditional or be able to be written as a biconditional is it needs a true conditional with its true converse. I hope I spelled that right. Okay, so conditional, converse, they both need to be true. Now, what are the symbols? Well, it's not going to be exactly like this, but it's very similar. The only difference is instead of an arrow going this way, it's an arrow going in both directions because both ways are true. So it's just a way to indicate that you can go in either direction, the conditional or the converse, and they're both true. How do you read it? Well, you read it by saying P if and only if Q. A lot of people like to start if P, if and only if Q. Okay, they make the mistake of thinking that it starts with if. That's for conditional statements, converse statements. It's not for biconditional. Biconditional starts with the statement. Now I'm going to write down a biconditional for you so we can break it down into the different parts, okay? So our biconditional statement is going to be this. Two angles, here we go, two angles are supplementary if and only if their sum, whoops, not theirs, their sum equals 180 degrees, okay? Now, let's think about this for a second. Let's think about the conditional and the converse. Okay, and I'm going to just pretend that this is our P and this is our Q. Okay, honestly, it doesn't matter which one you call which, but in this case, I'm just going to say this one's our P and this one's our Q. Let's come up with our conditional statement with these assumptions. If two angles are supplementary, then their sum equals 180 degrees. What do we know about that statement? Is that true or false? So let's copy this, put it down here. So P then Q, is that true or false? That is true. If two angles are supplementary, then their sum equals 180. That is a conditional. So that's the conditional. Okay, I'm going to abbreviate. Now the converse, is that also true? Okay, let's copy and paste this. Is the conditional also true? Or converse also true? This time we start with this guy. If two angles have a sum of 180 degrees, then they are supplementary. I know I kind of changed the words a little bit. I just wanted to change the words so that you could use it in an English sentence, okay? But pretty much the meaning is exactly the same as I have written it originally. So if two angles have a sum of 180 degrees, then those two angles are supplementary. That's Q, then P. That is the converse of the first statement we mentioned, and that is also true. Therefore, we can write it as a true biconditional. So two angles are supplementary if and only if their sum is 180 degrees. That's kind of like the crux of how biconditionals work. Now, as we understand this statement right here, that's a good definition. Supplementary angles are angles that add up to 180 degrees. So what are some of the prerequisites of a good definition in mathematics? Well, number one, it needs clearly, how about clear? Clear and commonly used terms. Okay, can't be throwing out lingo that not everyone knows. It needs to be properly defined. It can't be stuff you made up, and it needs to be clear. Number two, it needs to be precise. You can't have ambiguous stuff like almost or large or sort of or sometimes. Okay, those aren't clear, so those are out. Don't use stuff like that. It needs to be precise. So this example, we said 180 degrees. That's very precise. And, of course, it needs to be reversible. And that's what we're talking about with you need to be able to have a conditional with its converse. Both need to be true. It needs to be reversible. Let's go over some examples just so we can solidify this concept. Can the following statements be written as good definitions by combining them into a biconditional statement? A figure is a quadrilateral. A polygon has four sides. Now, if we want to consider P, and we could call this P, I suppose. We call this Q. We can kind of determine if it is, in fact, reversible. So we have P, then Q, and then, and then the Q, then P. Let me go to P. Here we go. And P. So the first one, obviously, is that one is the conditional, and that one is the hypothesis. Okay? So if a figure is a quadrilateral, then it has four sides. Is that true? Yes. Quad means four. So that is true. Quad means four, so it has four sides. I don't know why my highlighter's not working well. And then, so that statement is true. So this is a true statement. Now, a polygon has four sides if it is a quadrilateral. That is also true. So if it's got four sides, then it is a quadrilateral. Therefore, we can write this into a biconditional statement. Now, we don't start with if for biconditionals. We start with the hypothesis. A figure is a quadrilateral. This is our phrase here. If and only if. And we can just say it has four sides. You don't have to repeat a polygon, if a polygon has four sides. If it, because we already talked about the quadrilateral, if it has four sides. Or we can say this. How about I change it? Because polygon's a little bit different than quadrilateral, if it is a polygon, there we go. I feel better about this. With four sides. And a lot of times, these are just things you kind of have to add or subtract words. As long as the meaning is staying true, you're good, okay? Now, I get this question a lot. Can you switch it around? Can you make it into a biconditional that says, a polygon has four sides if and only if it is a quadrilateral? You can do that. See how I got rid of figure with that statement? But it's not too big of a deal if you add or subtract words as long as the meaning stays the same. And it's not important if you have the conclusion first or the hypothesis first, because it needs to be reversible anyway. So this is good written as it is. And then we need this, okay? This is very important. I'm going to put this in orange just so you can see that. All right, now second one. We'll call the first one P, second one Q. I'm not going to write the P then Q again. I'll just kind of refer back to it. A student is a sophomore, okay? Q, a student is in their second year of high school. So we have two statements and we can make it into a conditional statement. What would be the conditional statement? A student is a sophomore. If a student is a sophomore, then the student is in their second year of high school. That would be true. So this is our second example, okay? That would be true. What's the reverse? If a student is in their second year of high school, then they are a sophomore. That is also true. If both of those are true, then we can write it as a true biconditional. I'm just going to show you that you can write it as a student is in their second year, and let's just assume, I'm just going to save some writing, and if and only if, let me change it to orange, if and only if they are a sophomore. So I changed the words around slightly, but the meaning stayed the same. And you also notice this time I led with the conclusion, and it really doesn't affect it, okay? And I changed the words, so that's how biconditionals work. And these are good definitions. They're reversible, they're precise, second year, very precise, quadrilateral, 4 sides, clear and commonly used terms, okay? These are all things that make them good definitions. Okay, 2 more to do, and then you're done with this section. Determine if the following are good definitions. If so, rewrite as a biconditional. All right. A fish is an animal that swims. So I guess we need to come up with our own phrase here. So we have, if an animal is a fish, then it swims. How about, then it is an animal that swims? So if an animal is a fish, I'm going to do this time, just because we need to keep it sorted. If an animal is a fish, then it is an animal that swims. Okay, that's true. What about the reverse? Is the reverse true? That's the first place to start, in my opinion, with if it's a good definition. See if it's reversible first. Okay. Sorry, I keep trying to change colors. Okay. If an animal swims, then it is a fish. Okay. I know I just kind of said this out loud and I didn't write it down, but I hope you guys are getting this. Number one, we need if and then, so I added in when I said it. But notice how if an animal swims, then it is a fish. That is not true. We have dolphins that are not fish. We have humans that swim that aren't fish. So, oops, not true. So it is false. So we have a false statement there, so this is bad definition. Okay, this cannot be rewritten as a biconditional. So nothing more to do, it's a bad definition. A penny is a coin worth 1 cent. Okay, I'm just going to refer to this one. If it is a penny, then it is a coin with 1 cent. That's true. Okay, a penny is worth 1 cent. If it is a coin worth 1 cent, then it is a penny. That is also true. So guess what? These are clear terms. They're understood. It's precise, and it's reversible, so we can write this as a biconditional. A penny... how do I write this? A penny is a coin worth a penny. How about this? I got this. See, you got to kind of think about how to phrase this. A coin is a penny. There we go. If and only if. So I added some words here because otherwise it wouldn't have made sense. If and only if. And this time I don't need to write. I'm going to remove words, so I shifted it around. It is worth 1 cent. Okay, so there's our true biconditional. Hope this was helpful. Thank you for watching, and I'll see you next time on Wes Explains Best.